So next we have Dr. Massey speaking on comparisons of field scale irrigation use efficiencies for alternate rice irrigation practices.
Thanks, Drew. Good afternoon, everyone. As Drew had mentioned earlier, we're going to switch talks with Dr. Karki, who is going to follow me. Dr. Reba's will follow because ours are related, and hopefully I'll somewhat set up for Dr. Reba's talk that will precede this one. And the title is Comparison of Field Scale Irrigation Use Efficiencies for Alternative Rice Irrigation Practices, as Drew indicated. Perhaps another title would be The Perils of On-Farm Research. And some of our collaborators, I'd like to acknowledge those as well. The purpose of our study was to compare these four different irrigation management practices: standard cascade flood, multiple inlet rice irrigation, multiple inlet plus alternate wetting and drying, and then row rice on a working farm. We were also going to measure methane and nitrous oxide emissions, as well as water, vapor, and CO2, and also try to determine any benefits of these practices on water quality. And today I would like to mainly talk about the irrigation results and then share some of our practical learnings. The study site, and some of you may have been to a couple of the field days that have been held there in Mississippi County on this particular farm. It's the Sullivan's farm near Burdett, Arkansas, in the Arkansas Delta. This is a fifth generation farm. The son, Ryan, follows his father, Mike, and that's their wives there. I think probably as interesting as being a fifth generation farm, Ryan is a fifth generation college graduate. So I don't know as many fifth generation college graduates as there probably are fifth generation farmers. And the meaning why I mention that is they have a long history of allowing on-farm research going back at least 3 generations. I don't know about the previous 2 before that. It's a rice soybean farm. All the fields are typically graded to about 0.1%, and they also raise a little corn, and they typically follow a 1-to-1 rice-soy rotation, but for the purpose of this study, they allowed us to plant rice 2 years in a row. They allowed us to use 16 of their 16 hectare fields in a block. And as I said before, we were comparing irrigation use for row rice, cascade, standard cascade flood, multiple inlet, and multiple inlet plus alternate wetting and drying. So we have four replications of each treatment. And then in 2018, all the treatments got rotated clockwise except for row, since the beds already existed. Again, they grow on 38-inch rows. The farmers wanted to keep the row treatments in the same 4 fields, so those stayed the same and everything else rotated. We tried to keep everything as constant as possible, as you might expect. We used XL 753 hybrid from Rice Tech both years. The planting dates were similar. The flood dates were similar, averaging about an 80-day flood in 2017 and 18, and they were harvested in either late August or early September. They also allowed us to work with one of their better irrigators, Justin Ford, and he was managing these 16 fields both years. So again, trying to maintain as much consistency as possible. As I indicated, we measured the irrigation added to each of the 16 fields using flow meters. We measured water depths, soil moisture depths, soil moisture contents. Gases were measured in 2 different ways, actually 3 different ways. Dr. Arlene Adviento-Borbe, who will be speaking a little bit later today, used static vented chambers to measure methane, nitrous oxide, and CO2, as well as photoacoustic to measure nitrous oxide and ammonia, and Michelle used eddy covariance to measure ammonia, CO2, and water vapor. Of course, we did yield and milling. And this is just some of the shots of our treatments. So in terms of the environmental conditions, they were fairly typical years in terms of temperature, except in terms of rain. 2017 was 70% of normal rainfall, and 2018 was 30% more than normal rainfall, which made it difficult to get our AWD wetting and drying cycles in at the time period that we wanted. But we were able to get two good, solid dry downs in both years. So these are some of the data. So we have, again, 2 years of data, 4Fs each for each treatment, and I've highlighted some of the range of data, ranging for the Cascade treatment from 614 millimeters to about 1,100 millimeters. On the Massey range from about 500 to 1,400 millimeters. On the multiple inlet plus AWD, about 500, 480 to 974, and on row we range from 464 to 791. For averages that were, maybe it's confusing for me to switch, but I'm trying to point to both screens. So, averages were 823 for Cascade, 734 for Massey. AWD was about 700, and then row was about 632. There was a decreasing, I got another slide. So you can see that there was a decreasing amount of irrigation applied, but in terms of actual statistics, there was no statistical differences in the amount of water that was applied across both years. That's a bit disappointing when you're doing this to conserve irrigation water, right? So that is one of the things that we'll talk a little bit more about later. So, in terms of the trend in savings, we did see, a general trend that every time we added a management practice, we would start to see a greater savings, but that those results don't always end up to be statistical under these conditions. We're pretty confident that we had good we're particularly disappointed, for example, in the AWD not showing the water savings, because we know from the static chamber data that the methane emissions were reduced, showing that we had 2 solid dry downs during the growing season. One of the factors that, of course, that we had to deal with in our particular area of the state, we have high variability in the soil related to sand and clay contents, and that adds obviously an extra layer of complexity when you're trying to measure irrigation use. And you can see the variation in the sand and clay and silt contents. And part of the complexity is that in this particular case, everything was perfect about these 16 hectare fields, but the variability in the soil. But in this particular case, in working with the growers, this is land that they owned. And when they've got landowners that may not be as open to what they perceive as risks, then we go with our producers that want to cooperate, and then we work on the fields that they have available to them. So that's the reason that we're on these 16 fields. We were able to attribute the differences in water use according to clay content, as you might expect. And so one of the outcomes of this was, even though we applied different irrigation treatments, and we would have expected irrigation savings with multiple inlet, and then some more with AWD, and then row and AWD tend to be about the same, that this clay content kind of overwhelmed our management practices. And so one of the outcomes that we're still trying to grapple with interpreting the data, and hopefully coming up with some usefulness of the data, because we put a lot of time and expense into this these studies, and it just shows that kind of blanket statements about what water savings should be or can be have to also be taken into account with what the soils are, which makes sense, and we know that. In terms of rice yields, when we ran both years, there was a significant difference in that 0.02 p-value has to do with the row. These are the yield maps in 2017 and 2018. And won't go through all of them, except we can see something going on with these fields, particularly in 2018. That turns out to be the row fields. Again, those stayed in the same locations between 2017 and 2018. And one of the complexities, or one of the perils, as I alluded to earlier, was in this particular year, 2018 was the year that Loyan came out, and the farmers applied that to the row rice fields because of pigweed issues, but they did not apply it to the other 12 fields. And lo and behold, there was the label was wrong, and it caused considerable injury, about a 30% yield loss. So it was the herbicide injury that led us to a reduction in yield on the row, but otherwise we saw no differences in yield between the treatments. In terms of, I think I have a slide in here to talk about variabilities. Oh, sorry. Yeah, irrigation use efficiency, sorry. So in terms of kilograms of grain per millimeter of irrigation applied, again across the 2 years, we did not see statistical differences, which I guess if you were concerned about AWD or row, even in the year that we had significant herbicide injury, the statistics are such that we see about the same bushels per acre inch or kilograms per millimeter for the Miri and the AWD, and then on the Cascade versus the row, that's typically the row was one of the highest, except for the 2018 injury that we saw. So again, I guess if you were concerned about AWD and row, at least these data are showing no harm in the yield, except for the injury that we talked about from the herbicide. I wanted to show this slide because I've been concerned about this variation and the lack of ability to show differences with all of our hard work and and et cetera. This is a study that was published in 2017 based on a 12-year data set from the YMDs, the Water Management District located in Stoneville, Mississippi. They looked at irrigation use in the Mississippi Delta over a 12-year period, and in this particular case, they were able to, detect differences in irrigation use between Cascade, Miri, and then zero grade, which was not part of our study. But my point is that we had actually lower variation than what their study reported. You might expect that, given that this was over 166 fields, 41 fields, and 36 fields, with our range of irrigation falling within these expected ranges. So it made me wonder, I don't know if this is making any sense, but I started wondering, well, why weren't we able to detect differences from our field data? And looking at the statistical power of the YMD data, using these means and this common standard deviation and these numbers of observations, the N required at these levels of variation, at the 0.05 level, which should be about 10 fields. Well, obviously they had more than that. And at the 0.1 level, it would require about 6 fields. Does that make sense? I'm saying they had lots of observations, and so we were able to detect a difference, right? But in our case, we had 2 years, 4 reps each, so a total of 8 fields. That seems like a lot. It was a lot of work. But when we look at our values, and in this case, the most different of our treatments, Cascade versus row, the common standard deviation of 187 millimeters, sorry, this is all millimeters, we would have required, according to the calculation, around 12 reps or 9 reps, depending. I guess what I'm trying to say, really this is a conversation with me as I'm trying to grapple with the data. We did so much work and had such high expectations, and yet is it even realistic for us to expect to pick out differences with 8 reps on a field scale, on a farm, a working farm? And we controlled as much as we could control. We probably could have picked the fields better than we did based on the soil variation, and yet again, that's has to factor in the fields that are available. Am I doing okay here? Okay. Because there may have been better fields, but they weren't fields that they owned, and maybe that landowner did not want this type of research to be conducted. So that's kind of my point. So I kind of went through this exercise a little bit more, here's another comparison that we would have thought based on the YMD data. The 12-year data set that we should have been able to separate. But again, they had like 166 fields versus 41 fields. We had 8 fields. And based on our numbers, with this variation, we would have needed 30 observations or 22 observations. And we have 8. How many more years that we can conduct this work just to show that there's water savings? So it kind of points to the purpose of field work. What's the purpose of on-farm work versus it brings up the importance of small plot work, mesoscale work, and on-farm work certainly has a purpose, but maybe it's not what I had in my mind. So, yes, as we all know, on-farm research is fraught with difficulties. That's why the smart people stay away from farms, and when they do work, I'm just kidding. But if you worry about the reviewers when they come and say, "Holy cow, why is this like this?" I'm like, well, because some point you got to extrapolate out. In Dr. Henry's study, I noticed if I got this right, he did show a difference between Roe and Miri with a P of 0.0458, but you had an N of 17, which kind of fits what this is suggesting. We'd have to run this thing a couple more years to have any hopes that we would get the statistical differences that we hope for and that the reviewers might expect. So again, this is me talking to me. Realistic expectations are required. And it's interesting that the methane measurements, which we saw as a layer to the irrigation work, actually was helping us validate, maybe perhaps for the skeptical reviewer, that you even get an AWD treatment. We have soil moisture measurements as well. But the methane work that Michelle will talk a little bit more about after this will clearly show that there were reductions in methane, which point to the fact that it did dry down. So in a way, it's actually buttressing the irrigation work instead of the other way around. I don't know if that made any sense, but I don't know if I have any time for questions. Or if there's time for questions, if you have any questions. Yes, sir.
Joe, did you see any maturity differences among the treatments?
In fact, there would be, and particularly the first year of the row. In particular, again, this was a learning process for all of us and for the farmer. The most obvious maturity differences were in the row in 2017. In fact, they delayed the harvest of the row fields by 2 weeks, waiting for it to mature fully. I don't know if that makes sense, but yes, that's the main differences that we saw. And now they've refined the nitrogen application to where 2019 row rice was as uniform as any other rice crop that they've grown. But early on it was pretty spotty and a pretty thin stand. Yes, sir.
You fertilizing the same way in all your treatments?
This again, as Chris and Dustin had mentioned, or I think Dustin mentioned, but they typically, again, this is somewhat early on in their learning process. They were flying on an extra 100 pounds across the top. In the row. Yes, sir.
Any other questions? I've got one.
Yes, sir.
On your AWD, what threshold or scheduling or what method did you use to determine when to bring it back up or draw it down how far?
So Drew's question was, how did we determine when to reflood the AWD treatments? And I'm kind of an old school, even though we had the sensors out there. We're still struggling with sensors in a sharky clay soil, and we did have field tubes, but then you got one field tube in one location. So we walked the field, and when it was starting to crack in the top third to half, which is what I've been doing for quite a while because it's simple, then we would reflood. Because we're still struggling to figure out where to put the sensor, how many sensors, etc. Thank you, appreciate it.